Well, hello everyone, and welcome to Autel's next technical training webinar. Autel is utilizing our training and technical team during these unusual times to provide needed training for the automotive and trucking industry. We'll be doing these 1 and 2 times a month throughout the rest of the year. I see many of our distributing partners have people here, and you'll find some great information during this, but please understand, this webinar is intended for the technician and shop personnel and owner and not as a pure sales seminar, so it's going to get technical and deep in places. Now, I'd like to introduce today's topic expert, Chris Freeman. Chris has over 30 years experience in the transportation industry. He is ASE certified on medium and heavy duty vehicles and systems. He came to Autel specifically to help us develop our commercial vehicle and heavy duty platforms. And with that, I'll turn it over to Chris.
Thank you for the warm introduction, Mike. I would first like to thank everyone for attending today's training. We really appreciate you taking time out of your busy day to spend some time with us. Before getting started, I would first like to give a special thank you to each and every one of our technicians on here today. While the spotlight has been on the drivers themselves, those of you who are either strictly technicians or either owner-operators, those of you who work tirelessly to keep our trucks rolling in the rain, cold, snow, or extreme heat, this shout out is especially to you. Thank you for being on the front lines for my family and millions of other families to ensure that we have the supplies to survive these unprecedented times. We sincerely thank you. Now, one disclaimer for my friends in attendance from overseas. There is specific information included in this presentation that will only apply to the North American market due to the differences in communication protocol from J1939 here in North America and Euro 6 protocol everywhere else. While procedurally, some things may be the same, functionality may be different for our tool in your region. Next, I would like to introduce everyone to our guest moderators. This first gentleman is the only gentleman in my 30 years in this industry that I can honestly call a diagnostician. His cutting-edge diagnostic and advanced scope diagnostic training classes are just what this industry needs. He is a diesel technology instructor in the state of Washington with over 30 years in the industry. From Advanced Diagnostic Consulting, Brent Deffel. Lastly, but not least, we have a gentleman who is a factory-trained and certified technician with over 20 years of experience in the light, medium, and heavy-duty fields. He specializes in mobile maintenance from Ultimate Automotive Repair and Diagnostics, LLC, Johnny Croft. These gentlemen will be here to answer any questions about the Autel CV tools or any diagnostic questions you may have during the webinar. As Mike stated earlier, some of your questions may not get answered today due to the volume, but we will be responding to each and every one of you via email with answers after the webinar. Now, on to our topic. To be efficient, we must first understand the definition of being efficient. What is efficiency? It is the accomplishment of, or the ability to, accomplish a job with a minimum expenditure of time and effort. I repeat, minimum expenditure of time and effort. The question is, what are we doing as a market to help technicians achieve efficiency? First, we must understand the industry, where we are as an industry. Once we understand where we are first, we can then make a plan to go further. Again, we need to understand how it works before we can move on to provide a solution to the problem. Let's take a look at where we are today. A state of the union from an industry standpoint, if you will. We have a huge technician shortage. Either not enough are coming in, or too many are leaving after coming in, too many retiring, or just leaving the industry altogether. Why is this happening? What can we do to change it? Next up, we have uptime. I'm sure a good portion or a large portion of us have been yelled at about this at some point in time by someone who knows nothing about repairing a piece of machinery. These people yelling do have a good argument, though. It's their money at stake, their families being fed, companies needing to make payroll for their employees that support the business in other non-technical or technical roles. It's a legitimate gripe. These two we can kind of control from a certain standpoint. You can help mentor young technicians and develop them. If nothing else, train them in what you don't like to do. Uptime, you can kind of keep stuff patched together to increase it, but this only puts off the inevitable. The next 5, they're out of your hands. This is the OE market working against us. Technology is advancing at leaps and bounds. Limited standardization causes issue where things are never laid out from a same point from a bidirectional standpoint. Anyone who's ever performed a regeneration on a Sprinter van, then went to an MX-13 and performed a regen, and then on to a Cummins ISX, can feel my pain here. Next, we have multiple manufacturers on the vehicle. Okay, let's say you got an International with a Cummins ISX engine, Bendix ABS, Eaton automatic transmission, and a Navistar body control module. Now we're talking about 4 different softwares for one vehicle. Each one goes black, can't be used if it's not updated each year. Literally a loaded gun pointed at your potential ROI as a technician working on an efficiency bonus or a business owner trying to run a low overhead. Cross-pollination amongst manufacturers is becoming more prominent in today's world. There are manufacturers that excel at some things and worse at others. So we see a lot of them collaborate on platforms of machinery and vehicles to overcome these. Problem is, this can even cause more headaches to you, the technician. In case there's no available solution in the diesel engine selection, some manufacturers go back to the automotive market for a solution. Now, we have a normally easy to communicate with J2534 protocol that is now communicating only on a J1939 heavy-duty protocol. Now, couple all of what I spoke of previously, and with the fact that OE manufacturers are limiting bidirectional functionality to only be completed with OE software or with a web-based cloud program, now you can see why we have a technician shortage in this business. It's enough to make you want to pull your hair out. Let's go a little bit more in depth on the technician shortage thing. Some of the problems that we have go back to actual training. Okay, some of these guys are coming out of tech schools, and the problem is the tech schools, they rely on stuff that's donated to them to be able to use it. Okay, they don't have a lot of funds on hand, so they can't go out and buy the newest, greatest stuff. So you're not going to see a brand new ISX Cummins sitting in their shop. You know, more likely what you're going to see is going to be an N14, a DDEC 2, 3, or 4. Okay, so when they come out of school, yeah, they're great on those, but it doesn't really correlate to the market today. First thing they look at is an ISX or a DD16, and they are totally lost. Then from there, they get shunned. Okay, so once they get into a real world setting, we don't train them correctly. We don't mentor them correctly. Okay, that could be for a couple of things. It could be that the technology is too fluid nowadays. It's changing so constantly. Even veteran technicians, by the time they learn one technology, it's already moved on to something else that's newer in the market. Lack of proper technology understanding. I remember a time when they first came out with the DPF systems on these trucks. The OEs just kind of threw them out there and said, here they are. And we're like, how do we fix them? They're like, we really don't know yet. And they kind of left us in the dark. Lack of public information available on fast changing technology. So, you know, it changes, the technology changes so fast nowadays, there's no public information available on it because they can't make it fast enough. So technology is changing so quickly that they can't actually get the information out there on how to repair it. More technicians exiting the field. Again, if we could mentor more technicians when they come in, I think we'd have a better shot at keeping this a little bit more relaxed. Let's go back and revisit cross-pollination. On the screen you can see a couple of vehicles here. These are some vehicles that we're developing software for. You can kind of tell they kind of look the same. Well, they are the same. Body and chassis built by Navistar, who by the way is now owned by Traton, which is a subsidiary of Volkswagen, who also builds MAN and Scania in Europe. The engine it has in it, it's a Duramax engine. It's an L5D. It's an Isuzu commercial engine built by GM in Ohio. Allison transmission. By the way, the software is built by a third-party manufacturer, not Allison. And a Hydromax ABS from Bosch. It's an old system carried over from Navistar and Ford collaboration back in the 90s. Now you can see what kind of mess this truck is, okay? This is what's coming out into the market, guys. This is what we're going to be seeing every day, is stuff like this. Now that I've unintendedly discouraged everyone in this room, let's only try to control what we can control. Let's get into uptime. Uptime is defined as the vehicle being able to perform its intended function, which is hauling freight. This is my question to you. Mike will now present you with a poll to get your feedback. No answer is wrong. These are gathered from various manufacturer ideas that are currently in use today. It's just a personal preference to you to achieve uptime as an active technician or business owner. We as technicians can do some things to help uptime. One of those things is simplifying diagnostics. Okay, I've seen too many guys that, I mean, I love them to death, but they try to do things the hard way all the time. So what you can do as a technician is you can kind of keep some checks on yourself. One of those things being, if whatever problem you've got, you got to understand how that circuit works or what you're dealing with. What's it supposed to do? And you know, all throughout the system, if it's supposed to go through a relay and then the relay is supposed to close and then give power over here and the ground off the relay comes from over here, you need to understand that stuff. Okay, once you understand that stuff, it makes it a lot easier. If you understand how the system works, then it's a lot easier to go in and troubleshoot it, because now you know what it's supposed to do in the first place. Follow your path when you're troubleshooting from origination to completion. So I've seen too many techs, they try to jump right, what I call, in the middle of a repair. So what they'll do is they have a problem where it comes in. This is an example. Comes in and it's got a light out. Okay, he doesn't bother to check the bulb or the fuse. He goes in and starts pulling the firewall through connectors and starts testing for pin drag. Next thing you know, technician's got 8 hours on it. He goes back and works from the middle back to the origination and finds out, hey, it's a blown fuse. So yeah, now we've got an issue, because now we're going to try to charge a customer 8 hours of labor for a fuse. It's not really going to go over well. So some of the easy things that you can do there is just follow your path from origination to completion. Understand the variables that can affect origination. You've got circuit breakers, you got solenoid, switches, stuff like that can affect the origination of where the signal comes from. You know, understand that when you're learning what the system does. There's also variables that can affect completion. Shorts to ground, bad sensors, stuff like that can affect the completion of a circuit as well. You have to be able to see what can't be seen. You have to be able to see inside that relay how it works without opening it up. You got to be able to see inside that ECM what it's doing without opening it up. A lot of technicians, especially back when I was first coming into business, if they couldn't open it up and see gears and pistons in it, they didn't want to have anything to do with it. You've got to be able to see what can't be seen nowadays, because that's where the technology is going. You have to be able to communicate in a different language. And what I mean by that is you have to speak truck. And what I mean by speak truck is the truck is trying to tell you what's wrong with it, but it can't quite get that information to you to tell you exactly what's wrong with it, but it gives you an idea. So you have to be able to talk in what the truck talks in, so you have to be able to speak in what's called binary. Now, you also have to be consistent on how you diagnose issues. You can't go in and jump in the middle of things like I was talking about earlier. You have to be able, if you're going to do it from origination to completion, then do it from origination to completion. Don't shortcut yourself, because when you shortcut yourself, that's usually when you start digging a hole, and we all know what happens when you dig a hole. All right, have the ability to step away and regroup when necessary. We've all been to that point. I've been there myself, where you want to sling a wrench right through the windshield of a truck. Don't let it frustrate you. Walk away, gather your thoughts, regroup, think about it from a different perspective, and then come back to it. Usually you'll come up with a solution. Always be open to others' opinions, no matter what they are. The reason I say that is, I was in a shop one time where two 25-year Cummins techs were working on some M11s, and it had this issue. They were brand new M11s, and they all belonged to the same fleet company, and they actually had a stutter with no code as you drove down the road. Well, they decided to pull the engine harnesses off of them, were inspecting the engine harnesses, had the ECMs off of them, had them sent over to Cummins to check the calibrations in them and everything else. And a entry-level tech who didn't have anything else to do was going to bring one in for them. And he brings it in, and come to find out, he takes a look at it because he's got nothing else to do. He finds that the 4-aught cable that runs from the back of the alternator down to the battery was pulled too taut and was vibrating into the actual heat shield on the back of the alternator. This cut the wire, and every now and then the wire would cut the insulation on the wire, and every now and then under vibration the wire would jump down and arc off of it. As it did this, the engine would stutter as well. So he was able to find a problem in 20 minutes that those experienced technicians didn't find in 2 weeks. Always be open to others' opinions, no matter what they are. As I spoke about earlier, about binary and being able to talk like a truck, that's what we're going to talk about now. Now, I could go into an extremely complex math conversion to explain this, but we're going to keep it simple. After all, we're troubleshooting a truck, not building a space shuttle. To understand the ECM or control module, you must first learn how to operate. It's got a processor in it. This processor depends on sensors to relay information to it. The commands that the processor gives is based on that information it gets from sensor inputs. The processor gives commands by switching grounds on and off based on the before mentioned sensor inputs. These grounds are either in a state of connected or disconnected. This is denoted by the processor as 1 or 0 respectively. 1 or 0 is known as binary code. Now let's talk a little bit more about binary. I know I'm confusing some people here, so let's try to make this a little bit more simple. Okay, think of a series of light switches. They're either on or off, just like pressure switches I'm sure you've seen on trucks being normally open or normally closed. Old school guys like myself think of the dip switches on the back of a speedo head. Same principle. Either they're on or off. That's what the ECM does. All it does is flip switches on and off based on the sensor input information that it gets. Now, how does that binary work? Okay, basically, let's start with the most basic thing an engine needs to run, fuel. First generation TPS switches were comprised of 2 parts, an idle validation switch and a throttle position switch. They are now one unit together. The IVS controlled the idle. The TPS, when depressed, takes a 5-volt reference sent to it and runs it across a potentiometer or variable resistor, which then changes the voltage output coming from the ground side and notifying the ECM of the position, therefore informing the ECM how to adjust the fuel curve to maintain proper stoichiometry or air-fuel ratio. Here's an illustration of that and how that works throughout the circuit. Now that we have our input from our TPS at the ECM, what does the ECM do with it? The ECM will go through our light switches, turn them on or off, 1 or 0, based on the value sent, and send them to either an injector drive module or the solenoid on the injector. As shown in the illustration, the signal will then command the poppet valves to open and close at a certain rate of speed or pulse width. The injection in the cylinder is either completed by mechanical stimulation from the camshaft or in this case by high oil pressure. Now, as a technician, what are some of the first steps we can do to simplify diagnostics? Step 1, understand how the system works before troubleshooting it. Start where the process originates and work toward the completion. Do a visual inspection of the system before ever diagnosing. You wouldn't believe how many times people do not do this and it causes issues. I had an issue the other day where a customer called me up and they had codes that they couldn't get rid of. Come to find out, long story short, it was on a DPF system and they never inspected the DPF system for leaks. Come to find out, there was a sensor that was hanging out of the boss that was laying against the DPF. The problem with that was it was out of the airstream. Some people are saying, well, we could look at live data and actually see if it's in the if that was the issue. Well, the problem is this particular ECM did not allow for that to be read. What it did read was temperature, and because the sensor was laying against the DPF, The radiant temperature from the DPF itself was actually keeping it warm enough that it looked like it was in range. But the problem is the ECM was also looking for the parts per million to be able to adjust the emissions right. That's a reading that it doesn't show you. When they tried to actually go in and figure this out just by using a tool, it didn't tell them that. After they went and did a visual inspection, this is 2 weeks that went by, they looked at the DPF system and they found that the sensor was laying out. They were able to install the sensor back in. They went and road tested the truck and let the emissions readiness reset. And once it reset, there was no more problem. Make sure your tool has a proper bidirectional testing procedures before using it. There are a lot of situations out there where you go and tell somebody, yeah, I can do a regen on that, or yeah, I can program the injectors. Well, you don't have the test procedures to do it. Make sure before you even buy a tool, you know what the tool can test and what it can't test, and that way you won't get yourself in this hole. Make sure your tool has a coverage for that EPA standard before using. This is a big one in the industry right now in aftermarket tools. A problem is there's a lot of people out there, you can ask them, hey, do you cover bidirectional? And if they cover one bidirectional function, okay, on any EPA standard, they're going to say yes. The problem is there's different bidirectional controls for each EPA standard. And there's EPA standards that go EPA 07, EPA 10, EPA 13, you've got GHG 17, and they only cover certain years. Like a 7 will cover up to a 10. A 10 covers to a 13. A 13 covers to a 16. 16 covers to 17. So you need to make sure that your tool has the right EPA coverage before using. Clear your codes after making repairs. I can't stress this enough. I can't tell how many times I've looked into a truck that's got 15 codes in it and it hasn't been erased in 6 years. So make sure that you're clearing your codes after you're making repairs, because they go from active to inactive, and the last thing that a technician wants is to go in and see a bunch of inactive codes, because the first thing he's going to do is clear those, and I'm going to explain to you why that's a bad idea later. Diagnostic codes only tell you what the ECM sees as the problem, not what the problem is. So there's several problems that it can see. Let's use this as an example. Let's say your wife goes into their local auto parts store and they go in and they ask them to scan the code. Check engine light's on. They look at it. The guy tells them, yep, it's got a code for an oxygen sensor. You need an oxygen sensor. Well, guess what? Now your wife's come home with a $100 oxygen sensor, and that particular parts house that she went to does not do returns on electrical items. Now you're stuck with a $100 O2 sensor. And come to find out, all it was a vacuum leak or an intake leak or something like that. So certain codes will happen, and it can have multiple issues that cause that code. So keep that in mind. Always confirm a drivability issue before troubleshooting. This is another problem I've seen before. People will not drive it, they just take the driver's word for it. Go out, drive it, confirm that it has an issue before you even try troubleshooting it, because if you can't repeat the issue, it's going to be harder for you to find out what it is. Every truck has low power. My friends from the fleet world are probably laughing right now because they've heard this before. The issue is, you know, every driver comes in and says it just won't pull. It's just not doing what it used to do. Well, that's his way of nicely asking you without asking you to turn his truck up. The deal is, if it has low power and the scan tool that you're using has the ability to go out and do what I call dyno mode, you can go look on the placard that's on the engine and see what the rated torque is. Okay, then you can go out and you can hook to a heavy trailer, find you a hill, go up it, and read the torque that it's putting out. If it's rated at 1,735 foot-pounds of torque and it's pulling 1,735 foot-pounds of torque, it doesn't have a power issue. Some codes require readiness reset, like cars nowadays. Think about the truck I told you about a while ago with the knock sensor hanging out of it. When they put that back in, they had to go through a readiness. Now, those readiness, they change from manufacturer to manufacturer. Some vehicles out there, and I have the documentation to prove this, there are some manufacturers out there that require you can drive a vehicle up to 123.4 miles before it resets. This is not like a 6-mile little road test. It's not driving it around the block. You need to find out what the requirement is for that readiness reset before you even start to test drive it. Always road test your repair. Too many guys, they're like, I know what it is. They go out and they change that cam sensor and that's what it is. Well, guess what? It may be acting up under a load. Now you need to go out and do that road test to confirm that the repair is complete. Now let's move on to different types of codes. Everyone on here has seen this nightmare truck in their life. This truck has 29 DTCs. Where do you even start? Well, before you start, you got to understand what each code actually means. And there's different types of codes. Some of those different types of codes are active codes, inactive codes, pending codes, permanent codes, and cascading codes. Let's go in and break down these codes one by one and kind of explain what each one of them are. Active codes, this is a no-brainer. There's an issue that's present right now. This is something that needs attended to right now. It's happening as we speak. Inactive codes, they were once active at some point, but now they're not active. Okay, so they're not happening now, but they've happened in the past. Pending codes. Pending codes are intermittent faults or faults that the ECM needs to see happen in 2 consecutive warm-up cycles to set the code. If the fault does not reappear within 40 warm-up cycles, the code will be cleared from memory. A pending code can become an inactive code, theoretically. Permanent codes. Permanent codes are designed for emission systems primarily. These versions of active codes cannot be cleared until the emission system is properly repaired. Once the repair is performed, the ECM can go through a drive cycle or readiness to recognize the issue is solved, and then it goes inactive, therefore it can be cleared. Cascading codes. These can be a pain. These are active codes that are caused by the ignorance of an active fault or issue. They can be set from various codes and usually consist of 2 or 3 codes themselves. Therefore, they cascade from an original code. A little bit more into inactive codes. Inactive codes can be codes that weren't erased from previous repairs. They can be codes caused by an intermittent issue. You know, it's happening now, it's not happening now, that kind of thing. They can be intermittent permanent codes. So it was a permanent code that stayed on for a long time, and then now something has happened to make it heal itself, and now it's gone to an inactive state. Or they can be intermittent pending codes. So it's something that could have happened for a certain amount of time, and then it was resolved after driving it for a little while longer. So we all know that it didn't resolve itself. It's a problem that's there. It's usually some sort of intermittent thing. Now, pending codes. Pending codes can correlate to active codes, so they can actually be an active code without even saying they're an active code. They can show inactive if the history has not been cleared. Show as the only code in some cases. They're not included on all ECM applications, so some manufacturers out there don't even use them. It's a certain few that use pending codes. Now, on to permanent codes. Now, permanent codes can end up causing cascade codes. Being part of the being related to the emission system, these are going to be the ones that end up causing a lot of your D-rates. Okay, the D-rates are actually caused by the cascading codes because of an emissions problem. You're going to see these a lot in DPF scenarios as well. They can be the most confusing of them all to diagnose, because now, you know, if they do end up causing cascade codes, now you've got 4 codes instead of 1. So it's like, where do I go first? Which came first, the chicken or the egg? So we're going to talk a little bit later about how you figure that out, but as far as which one comes first, but this can lead to some confusion. Now, these can show as active, inactive, or pending as well. They can actually double up in some cases. They can also work as a tampering code for the emission system because they are emissions only related. If someone tries to remove something in the DPF system, it's going to throw a code and it's not going to let you do anything, and it's going to end up, or it's not going to let you, it's going to throw that light, and then eventually it's going to go to a derate, and then it's not going to let you do anything until you get it fixed. And these permanent codes, they only apply to certain manufacturers now, but I guarantee you guys, in the short time, all manufacturers are going to have these. So we need to pay attention to these and learn how to deal with them now. Codes. These are the ones that get a little hairy, okay? They are only caused by other codes, okay? They can be active, inactive, pending, or permanent. So they usually happens in stages of disregard. So, for instance, 10-hour time frames measured by the ECM time. Now, how they happen is following a solid yellow check engine light. Okay, the light comes on, the driver sees it, he's still got to drive. So after 10 hours of ignoring it, then the check engine light starts blinking. That sets an additional fault. Driving 10 more hours and nothing is being done, the solid red light is set along with another code. So now you have two cascades. Now, if you drive for 10 more hours of solid red, then it starts blinking. This sets another code, which is also a derate code in most cases. They can be caused, like I talked about, inactive, active, pending, or permanent. Okay, so you have to be careful. Those are the routes you're looking for. You're not looking at the cascading codes, you're looking for the route. When you have a cascading code, do not clear any codes. Doing so can remove an inactive code that is a root cause. Like I said before, I can't stress this enough, cascading codes are caused by other codes, and you're looking for the root. Okay, the root is where the problem, what the ECM is saying the problem is. So you can go in and then troubleshoot that code from there to find out what's going on. Definitions are important when you're working with a tool. Here's some of the definitions that we supply in our tool to help people troubleshoot their problems that they may have with a particular code. You can go in here and see the reason it's happened, circuit description, component location, some action taken when it's active, and then also some shop talk stuff. Back to our nightmare, 29 codes. How do we isolate these codes to figure out where do we even start? Let's talk about that a little bit. Now, using the Autel tool, let's show you a little bit about isolating codes, or how we do it. Here's your DTC. You can see that it's active. Now, over to the right, you can see something that looks like a little snowflake. That is actually freeze frame data. Okay, we click on that, and then that's going to give us the actual freeze frame data. Now, isolating these codes, you can actually see what time they actually occurred depending on what time is on the ECM now. So you can see how long it's been since that code actually occurred. The way you do that is in your freeze frame, you can scroll down to the actual ECM time. Okay, it's actually marked right there. Now from there, you can actually back out of this down here on the bottom left, hit that button, and you come back out to this screen. Then you go into live data, and then you can actually scroll down and find the ECM real time in this data, denoted by the circle there. We have those. We're setting a timeline of the event. As you can see in this illustration, that our current time is 91:03, 19, and 15 seconds. This code actually occurred at 91:03, 15, and 13 seconds. So basically, 4 minutes ago, this is when this happened. So you've got a timeline of when this code actually occurred. There's something entirely different I'm sure you guys have actually had some symptoms where you had a symptom on a truck, drivability issue, if you will, and you have no code. Where do you even start? Let me explain to you why you have that code in the first place. Okay, what is failure in range? Every ECM has a reporting value range that is predetermined by engineers and set in the processor as a functional range for a sensor. Theoretically speaking, a 5-volt sensor will top out at about 4.7 volts, and the low setting where it actually fails may be set at 2.5 volts. Let's say that this sensor is running at 2.6 volts. Okay, it's just above the functional range, but it's enough to give a symptom, but it doesn't give you a code. Some of the things that you might see is erratic engine performance, erratic shifting if it's an automatic transmission. It can cause ghost codes. It can cause codes for systems down the line. Okay, fuel problems caused by DPF, or fuel problems can cause DPF problems. It can be defined as intermittent. Most cases will not set a code for the component with the actual failure. I know a lot of you guys are saying, oh, well, that's great, everything's great, but you're not telling us how to fix it. I'm going to give you a couple of tips that you can use. These are going to be generalized. It's not going to be an exact fit to your particular issue, but here's some of the things you can do. First, you got to know how the system operates. Okay, you got to know how that particular system operates. If it's got a hesitation to it, it could be electrical, it could be fuel. Okay, so you need to diagnose those two systems. Okay, you have to know how you may go all the way through the fuel system and there's no problem, and then you go through the electrical system and find a problem. But you have to diagnose that first. That's how I would diagnose it myself. I would diagnose the fuel problem first. If the fuel problem's good, then, or fuel issue's good, then I would move on to the electronics. When you get to the electronics, use a good quality oscilloscope. Some sensors can't be read with graphing alone due to screen refresh technology that are in tools nowadays. So it has to read at a lower frequency. The problem can happen in fractions of a second. Oscilloscope can catch this due to that low frequency, the rate that it records at. A random misfire, for instance, you can actually use an infrared temperature gun that could catch a difference at the exhaust, a temperature difference at the exhaust manifold, for instance. A injector that's not firing all the time or firing every now and then will be colder on the exhaust manifold at that particular cylinder than it will be at others. Corrosion, oxidation, loose connections, even humidity can be a factor in causing resistance if it's a wiring issue as well. Recognizing faults that cause other faults. There's a lot of that goes on as well. For instance, exhaust brakes can cause DPF issues. In Isuzu's particular, an exhaust brake where the butterfly flap is actually stuck, it can actually cause an issue in the DPF where it's filling it full of soot, where it's not closing all the way. So that can cause some DPF issues. So it's real common on a Isuzu where you have to regen it more often than you would have to on another one. Injectors can cause no crank issues without leaks being present. To give you a symptom like the fuel is falling back, say it's losing its prime, as we say in the industry. Okay, the fuel is falling back on it. It can be falling back the other way, because most people, what they'll like to do is they like to pressurize the system, get out a bottle of soapy water and spray it. You know, fill it up with compressed air, fill the lines up with compressed air, spray it, look for bubbles. Well, the problem is if you don't have a visible leak to the ground and it's not what we call sucking air, what can happen is the injectors can actually cause this issue. And what it does, instead of falling back into the fuel filter, the high pressure is bleeding off through the injectors and then falling back into the return and returning into the tank. Another problem that a Isuzu has. DPF issues can inadvertently cause an SCR issue. An explanation of that is I had a friend that had an issue that was dealing with this where it actually caused it was the Cummins, and it actually caused an air intake derate. They went in and they actually tried to figure out what's going on, because that was the only code they had. Okay, so first they checked the intake pressure and it was high, but then they checked the exhaust pressure coming out and it was also high. How can that be? Because that's separated by the turbo, and the pressures were equal on both the prop pressures were equal on either side. Got to thinking about that, and it's like, how can that happen? It's almost like someone sticking their hand over the tailpipe. Well, got to looking at it a little further, and what had happened in the long run was the DPF had imploded and had jammed itself in the pipe between the SCR and the DPF. The problem with that was the SCR was unmonitored. Okay, so it wouldn't give you any feedback, and it had already passed the DPF or the knock sensor on the back downstream of the DPF, so it couldn't tell the issue. That's what happened. It had clogged the exhaust completely up and was backing all the exhaust back into the intake. An exhaust issue can cause an intake pressure issue. Exactly what we're talking about. Common issues with ABS sensor faults originate from previous brake jobs or when wheel seal replacement. I've seen this a million times on ABS. I can't tell you how many times I've seen people do brake jobs and they do not adjust the sensor after they do the brakes, and now they have ABS issues. Well, then they bring it in, and come to find out, the first thing I ask them is, have you had a wheel seal replaced lately, or have you had any brake work done on it? And come to find out, yes, I have. Then most of the time, what all I had to do was slide underneath, push the sensor back in to adjust the air gap, drive it on a road test to adjust that air gap, and then the problem's gone. Intake leaks can cause internal mechanical failure. How many times have you guys seen where, especially on like dump trucks, where you have an intake leak, air intake leak, and it sucks in dust? It can actually cause the rings to file down and lose compression. Then you can have various issues, but one of them could be if they're filed down bad enough, then it can't build up compression inside the engine and it goes to a no start. Internal mechanical failure can inadvertently set fuel or exhaust faults. Let's say you have a rocker arm that breaks on an injector, okay, or a spring on a valve collapses. That can make you think, oh, well, I've got a dead cylinder, I might have an injector issue. Those are the kind of things you need to look for as well. You need to look for that all the mechanicals are there, and before you even start on the electronics. Bottom line, a fault is a starting point, not the solution. Now, let's move on to understanding software coverage. Like I talked about earlier, you need to know what your software will do before you get it in your hands. Here's an example of one of our competitors out there and some of their coverages. If you notice on this particular one right here, they skip completely over the Caterpillar 3128 altogether. Okay, some of this coverage is only up to EPA 13. Some of this coverage is only up to EPA 10. There's a lot of issues. They can't. One's only up to 17. If you have newer vehicles, 20, 19, or 18 vehicles, this software is not going to work. So you need to understand what the coverage is of the software that you're using. The correct questions are extremely important. Just asking if does it have bidirectional, that's not enough. Staying on that same thing, are your bidirectional controls enough? What does your solution offer? Here's what our solution actually offers. These are a few of the tests that we can do on some of the vehicles that we offer. You can see stuff from graphing here. You can see that you can see PIDs during some certain test. You have, set up for a dynamometer. You can go in and do parameter changes. You can go in and do cylinder balancing tests, compression tests, so on and so forth. So does your tool have the horsepower to do the stuff that you need it to do on a daily basis? Let me tell you a little bit more about our Autel HD solution. Some of the tests that we can do: cylinder cutout test, auto and manual, cylinder compression test, DPF and SCR reset, VGT testing and relearn, EGR functionality and relearn, DPF forced regen, DPF derate lockout reset, road and cruise speed programming, auto trans clutch reset, ADAS dynamic relearn, injector trim programming, driver rewards programming, tire revolution programming, DPF pump testing, common rail injector testing, engine protection programming, multiplex programming, anti-theft protection programming, PTO programming. We also include trailer software on our tool as well. It's standard. We can also do trailer ABS modulator tests as well. And we can do many, many more. We have over 2,000 bidirectional controls covering 126 models and counting. Now, let's talk a little bit about the Autel HD lineup. We offer 3 different tools. Our first is a little handheld device. It's an AL529 HD. We have a mid-grade unit, which is the MS906 CV, and then we have our professional unit, which is the MS908 CV. Now, let's go a little bit more in depth on each one of these. AL529 HD reads HD OBD2 standard, J1939 protocol, J1708, J1587. It has the ability to read codes, clear codes, stream live data. It reads all engine, transmission, and ABS codes. Connectors included are the OBD2 for the Volvo Mac, the 9-pin Deutsch, and the 6-pin Deutsch. Now, all of Autel's connectors are compatible to either the pre-2016 gray connectors or the post-2016 green connectors. So, theoretically, the difference between the two, the gray connectors actually communicates on what they call 250K baud, and then the green ones, they actually communicate on a 500K baud. So our connectors will work with either one, okay, and that goes with any connectors that are associated with any of the tools that are following this as well. So you do not have to buy an extra connector like you do in a lot of our competitors. And the updates for this tool are free for the life of the tool. Now, building on the 529 HD is the MS906 CV. It has the same functionality as the 529 HD, but it does add stuff. It adds auto scan capability, adds the ability to complete DPF regens, adds the ability to reset DPF derate lockouts. It adds a service reset functionality for light, medium, heavy-duty vehicles. Has a customer tracking app that you can actually put your customers in and keep track of their repairs with. There's a repair information access portal, so whatever repair information you use, whether it's CAT-SYS, Quick Serve, Volvo Mac, Detroit, Mitchell, Motor, whatever's your favorite, you have access to it as long as you have your username and password. It's connected to internet. You can then log into it and get your favorite repair information through that portal. It has CV service and expert modes for expedited troubleshooting. CV service is basically a place where you would go to do quick troubleshooting. If you need to do a regen real quick, you need to do an injector cutout test, you could use that without going into the full software. Expert modes, basically what that does is that's just like using, let's say, like Cummins Insight or CAT-ET. You could go in and just look at particular engines or transmissions or ABS systems if you only have a problem in one of those areas. Okay, it can record live data and do playback. It can take videos and photos. It can be remotely logged into via TeamViewer. Customizable health reports to include company headers and logos. So you can print out a customer health report, give him a status on his truck either when you're checking it in, or you can give it to him afterwards to show him what repairs may be needed down the road. This is our offering as a service triage tool for a road truck. So any service trucks you got out there, this is the one we recommend because it has the correct amount of functionality for a service truck. You're usually going to do your larger repairs in the shop where you're actually going to have your professional tool. Okay, bidirectional controls are limited on this. Heavy duty rugged construction. Yearly updates are optional as the tool does not go black. Now what that means is if you do decide not to update your yearly subscription, you can still use the tool. What's going to happen is you're going to stop getting updates. But you can use the tool. We're not going to hold a gun against you and say, hey, you've got to get this yearly update or we're going to turn your tool off. Now, When you do buy a subscription, it's called a total care package. Now, what we do for people that buy this is when you buy a tool, straight out, when you buy it when it's brand new, the tool comes with a 12-month warranty on the hardware, and it also comes with 12 months of updates. Okay, once your year is expired, okay, and it's time to update it again at your choice, if you do decide to update it, we're going to give you another 12 months warranty on that hardware. And this happens every year. So if you pay for your subscriptions every year for 5 years, you've got a 5-year warranty on that tool. If you pay them for 10 years, you've got a 10-year warranty on that tool, and so on and so forth. The update on this is $795 a year, and like I said before, that is optional, and that's manufacturer's suggested retail price. So you may be able to get that a little bit lower if you buy from one of your distributors. Let's talk about the professional tool. Okay, building on the 906 and the 529 is the MS908 CV. It is a combination of both with even more functionality. Okay, it has adjustable parameter programming on engine, transmission, ABS, aftertreatment, ADAS, TPMS, and it covers all makes and models currently in the market. Full level OE bidirectional testing and relearning processes. I can't stress you how important that is to be able to have that coverage for the models and the years that we cover. The coverage years cover from 1990 up to 2020. This includes bidirectional functionality. Covers vehicles from as small as an S10 to a Ford Ranger pickup up to large industrial engines such as a QSK50 Cummins. It's a professional level tool. It also includes an adapter. Okay, this adapter, this universal adapter that we call the Uni 4, is basically for anything that we do not have a plug for. So if you're working on a power unit and it doesn't have a 6, a 9, or an OBD2, it's got something else. If you know the pinout of that connector, okay, we offer you this connector to be used in liaison of any other connector. So you can kind of make your own connector. And the pinout, we actually provide that in the tool. It's under our Academy tab, and then you go from there to Operation Manual, and then from there into Uni 4. Under there, you'll actually see a wiring diagram that gives you a pinout of that plug. Now from there, you can actually use some adapters that are included in a canvas pouch that we include on the Uni 4 connector, and then use that to plug into the DLC connector on the piece of machinery that you're looking at, and that's going to be able to give you the ability to read codes, clear codes, stream live data, and if the vehicle has if the engine needs any bidirectional functionality and we cover it for it, you will be able to do bidirectional from there as well. The yearly update is optional on this as well. Same thing applies as far as warranty coverage as well. MSRP on this update is $12.95 US. Now let's talk a little bit about return on investment. Return on investment, this is basically a 5-year run rate of what it would cost to use an Autel versus a well-known competitor. Okay, notice that the cost does not include additional OE software needed to compensate for the massive difference in bidirectional control needed for this competitor unit. As you can see, there's only a $700 difference between the competitor and us. The annual renewal fees are a little bit more as well. 5-year run rate, this is also on a laptop as well, where we're on an Android system. Android systems typically last longer, so if you're looking at a laptop system, usually they have to be replaced every 3 years. So this takes in effect of that as well. Now if you go down to the brands covered, you can also see that my competitor only covers 42 brands. We cover 126. Okay, now their bidirectional controls are less than 260. We have over 2,000. Now my question to you is it worth that $7,000 difference knowing everything you know now? Possibly not. But these are more of the reasons why you need to understand a tool and what it does before you buy it. Now that I've told you everything that the tool has, let me tell you about what it doesn't have, and we can actually have some add-on solutions for you. Like I said before, the trailer software is built into the tool, but the PLC adapter that's needed to use that is a separate item. Some other things that we offer as well is video boroscopes. So you can actually use those to do diagnostics on engines before you take them apart. And we also offer 4-channel scopes as well. Now let's talk a little bit about the TrailerPLC. Yes, that's the part number I chose. Don't judge me. What this allows you to do, okay, is it allows you to actually, you've got a choice of how you connect here, okay? You can either connect between the tractor and trailer itself and have the tractor supply the power to the center pin, or you can actually do this in a standalone mode where you just actually apply power to the little power adapter that's offered there in the top of that T there in the side of it, as you can see. This goes along with our 908, okay, our professional level tool. You can actually plug in the power source that's provided with your 908 kit, and that will supply the proper power to the center pin on the ABS to allow you to be able to read ABS trailer brakes. This also comes with a 1-year warranty as well. Now let's talk a little bit about video scopes. We have 2 that we offer. We have a 480, which is a dual camera, and then we have a 460, which is a single camera. Not only do they have all these features here, but the single, let's talk about the dual camera first. The dual camera has a camera on the end, and then it has a camera on the side that reads 90 degrees from the tip. So you can actually see those hard to reach areas. It also has lights on both of those as well that are adjustable, so you can get into tight places and be able to see everything you need to see. The 460 has a single camera. These are high resolution cameras. They do have a 4.1 inch color LCD display on them. They also allow you to record video and also to take pictures that you can send off or email to customers to show them what you're actually seeing as a technician. Now onto the MP408. This is our 4-channel oscilloscope. It's got a lot of great features, and it is probably the most affordable on the market. Now this goes along in line with our 908 professional tool as well. The scope screen is already built into it. There's an app you can use. You just connect it via USB, and you can do everything on the tool that you need to do from there. Actual specifications on the MP408, you can see that it reads down very low. The sensitivities, 10 millivolts, and it is a great tool to be able to use and find those hard to find problems that you have out there on a day-to-day basis. Next up is our infrared gun. This is something I didn't mention previously. It's our IR100. Now this is like the thermal imaging camera I was telling you about with the injector problem. This is something that you could use to find out, okay, what is the actual temperature that I'm getting coming out of my exhaust manifold. This also works great on radiators, finding blockage spots on radiators, finding blockage spots on condensers or evaporator cores. Very good tool. I couldn't recommend it enough. It has great resolution, very good color palettes that you can tell between hot and cold, and it also includes a 1-year warranty as well. Now, your Autel CV North American team. Yeah, this guy kind of looks like Jesus, but it's not. It's actually Lou. Lou is our HD tech support. He's in New York. Here's his contact information that you can reach out to him at any time if you have any questions. Please feel free. And if you need more help, this is me. My name's Chris Freeman. I'm the Director of HD Sales and Training for Autel North America. There's my contact information. Please feel free to reach out to me for any questions that you may have or concerns. And I promise you we'll get on them as soon as we can. Thank you for attending. I hope all you guys were able to learn something from this, and hope you have a great day.
Thank you, Chris, for some great information there. For our next technical training webinars coming up, probably in about 2 weeks, we'll be starting to deal with some of the automotive diagnostics. And future webinars will get into ADAS systems as well as into our scope, and then back through our TPMS and more on the heavy duty. On behalf of Autel, our group of guest panelists, and Everybody, I want to thank you for joining us today, and you all have a great rest of your day and stay safe out there. Take care.